So this question says that the complex number u is defined by u equals 5 upon a plus 2 iota, where a is a real, where the constant a is real. Express u in the form of x plus iota y, where x and y are real. So we will need to rationalize this. That means we multiply and divide it with the conjugate pair, which is a minus 2 iota. In the denominator, we're going to apply the identity a squared minus b squared. Numerator becomes 5a minus 10i. So 5a minus 10i upon a squared minus, this will become minus 4 because iota square is -1. So we get a square plus 5 in, a square plus 4 in the denominator. Now I'm going to split the denominator underneath the real part and the imaginary part. A square plus 4 here and a square plus 4 here. This is the answer. Okay, first part is done. Part 2, find the value of a for which argument of u conjugate is equals to 3 pi by 4. So let's write u conjugate first. It's going to be 5a over a square plus 4 and plus 10 iota over a square plus 4. Okay, conjugate of this, the argument of this is going to be tan inverse y over a. So argument of u conjugate would be tan inverse y upon a. Y is the imaginary part upon the real part. Okay, the denominators cancel out and we get tan inverse 10 upon 5a, which is going to be 2 upon a, and the answer is 3 pi by 4. This is already known, 3 pi by 4. Send tan to the other side, so we get 2 upon a equals tan 3 pi by 4, which is -1. So a is equals to -2. Part B, on a sketch of an Argand diagram, shade the region whose point represents the complex number z, which satisfy both the inequalities modulus of z is less than 2 and modulus of z is less than modulus of z minus 2 iota. All right, so the first one, which is modulus of z is less than u, is actually a circle whose center is 0, 0, and radius is 2. So we're going to draw a circle with center 0, 0, and radius 2. So something like this. This would be 2, -2. Oops. Sorry. -2. Oops, why does this move? And a 2 here and a -2 here. Okay. Next, we need to draw this. This gives us the point 0, 0 because it's z minus 0 minus 0 iota. And this one gives us the point 2, 2. And we have to plot the perpendicular bisector of 0, 0 and 2, 2. Let's plot these 2 points 0, 0, 2, 2. The perpendicular bisector means a line which passes through their middle, so somewhere over here, and is perpendicular to this line. So it will also make a 90-degree angle. So something like this. This would be the perpendicular bisector passing almost through the middle of these 2 points and making a right angle with this line. So we just need the perpendicular bisector and not the other line. So this could go. Okay. Do show the point 2, 2 though. All right, so that's the perpendicular bisector. And now we need to shade the required region. This part says that the shading needs to be done under the inside the circle because it says radius is less than 2. So we shade inside of the circle, but we're not going to shade all of it. We will also take into account this. This says that you shade the side uh, which is towards this point 0, comma 0. So we also always shade the side towards the less than symbol. So that's the 0, 0 side. That means we will be shading under the line, not above the line, and we'll stay inside the circle. Both of these lines, however, need to be dotted because it's less than and not less than equals to. So in case like me, if you end up making solid lines, what you can do later is make dots on it. So you can make like dots on it. And that would mean that this line is not to be included because it's just less than and not less than equal to. It would be better if you could make partial lines to begin with, but in case you overlook that and remember it later, so then you can just make dots on it. So same on the perpendicular bisector line.